Hello, everyone. It's good to see you, everyone, here in sunny California. It's not so sunny in Poland right now. I can tell you that, but it's mostly because it's night. So we're here to tell you about our data platform journey with Presto and Bolt. So first off, let's introduce ourselves.
Hi everyone. Well, you maybe already know me from the panel, but I'll reintroduce myself anyway. I'm Kostya. I've been working on Bolt's data platform for quite a few years, and I led the project to migrate from our monolithic old data platform architecture to open lakehouse architecture, which I'm going to briefly talk about in this presentation.
Thanks. My name is Przemlyslaw. You can call me Shem. That's way easier. So I'm going to talk about the data platform present and the data platform yet to come. So first off, how many of you know what Bolt is? What kind of a company? Can you raise your hands? Okay, yeah, not bad, not bad. So just a few words to get you up to speed and convince you that we are serious with our data platform engineering. So first of all, Bolt is basically a mobility company. We have 5 core products, and we operate mostly in Europe and Africa. So unfortunately not in the United States, but if you're traveling, give us a try, check us out. But that's mostly to tell you about our scale. So we have quite a scale, and it just tells that we need to have efficient systems to handle what we got. And what makes us stand out is that we are not a gigantic company, but we compete with giants. And in order to do that, we have to be smart, and we have to do more with less. We really need to be cost effective. And in fact, cost effectiveness is in our company culture. It's so deep that I'm going to probably talk about cost effectiveness much more in this presentation. And we need to be pragmatic. We need to take feedback seriously and concentrate on the existing problems. So that's for the introduction. And now to start the presentation. Do you know a novel, Christmas Carol by Charles Dickens? So some of you know, okay. Again, just a few words. It's about the guy on the front cover. His name is Scrooge, and he's a very mean person. He likes money but doesn't like people. Sometimes I can relate to that. But one day he gets visited by 3 ghosts. Ghost of the Christmas past, the Christmas present, and the Christmas yet to come. And this is a wake-up call to him. And because of this visit, because of this experience, he understands his mistakes, and he knows what to do to be a better person. And so we are also going to talk about ghosts, kind of, data platform ghosts that haunt us and challenge us all the time, but they also help us create a better product for our users. So let's start with the ghost of the data platform past. Over to you, Kostya.
Okay. As promised, I'm gonna talk about what got us here to where we are today. This is a brief schema of our legacy data platform architecture, which you can call a monolithic architecture because everything was centered around Redshift. We had one of the biggest Redshift clusters in Europe, and basically it was hitting, I would say, the limits of what Redshift is capable of. Everything was running on Redshift, from data ingestion to any data transformation by jobs, to BI, interactive queries, ad hoc user queries, well, everything. And most of the data was stored in Redshift. We did have some external tables on S3, but that was not a huge percentage of our data, relatively speaking. This architecture got us to the place where we were at when I joined. It served the company quite well up to a point. So I wouldn't criticize it too much, but yeah, it stopped working around when I joined. So we started looking into something else. And to briefly talk about the challenges that we were facing, one of them was hitting scalability limits of Redshift. As I mentioned, we were not able to cost-effectively scale it anymore, even utilizing features like concurrency scaling. The other thing is we had trouble scaling to peak load. Most of our load comes on Mondays and Tuesdays from our analysts when they fire some heavy reports and queries. And we had troubles getting things to work on these days at all. And the other problems that you would face in such a monolithic system is a noisy neighbor problem when someone fires off a huge query and it basically kills performance for other people. And in this case, it can even affect things like data ingestion since it's running on the same Redshift cluster. Cost attribution was also a challenge. So we didn't really have a good understanding of how much different verticals cost us. We went through quite a long POC phase to choose our next technology stack and architecture. We ended up going with open lakehouse architecture. And at the time, we chose HANA Presto, which was later acquired by IBM, which allowed us to go with Presto, but not run it ourselves fully because we were a pretty small team and we still are a pretty small team. It took us about a year to fully migrate to the Lakehouse architecture, which I would say was quite a wild ride. And we had some people from HANA coming over and helping us with certain problems like optimizing, for example, metadata caching and optimizing three-list caching. And yeah, some of these OG HANA people are with IBM right now, and you can see them on the conference. And thanks a lot for the help. And during this period, we also had a bunch of memes in Slack about how Redshift is not loading data, and like some memes that I'm sitting here bored while Redshift is loading data. So we had a lot of pressure to get this thing running, but we managed to get it running in about a year fully and turn Redshift off by the end of it. And with that, back to you, Przemek, to talk about the present.
Thank you. So migration was done, and I'm proud to say that since we finished the migration, we have received 0 memes about bad performance. So if you got one metric out of all of this, this is pretty important. So this is our data platform setup. It's not the whole data platform, but just the part relevant for today's presentation. A few important elements on this diagram. We have 2 engines. There's Presto and there's Databricks. And we use Presto to read data, obviously, because Presto is good at this. And Databricks for a bit of reading, but also writes. And as you can see, there are a lot of open technologies that we use now since we migrated to the modern Lakehouse architecture. So we ingest data from operational databases or some other external tools as well. And we also have dbt models that create some new tables in our warehouse. We store data on S3, mainly in the Delta format. And the metadata store is AWS Glue. And we use Presto mainly for BI as a backend for Looker, but also for ad hoc queries by our users. So let's look a bit closer at our Presto setup. So To mitigate the noisy neighbor problem, we have dedicated clusters for ad hoc queries. So those can be quite wild and unpredictable. So we need a separate set of clusters for those. We also have a separate set for automated workloads. Those are mainly backend jobs connecting to Presto for some report generation, things like that. And most of all, we have dedicated clusters for BI by vertical usually, because every vertical needs to make educated business decisions, and they do it based on what we have in Presto. So this is like very important for us. So we have, and actually over half of our company uses Looker every day. So we have a lot of load on Presto. We have hundreds of thousands of queries every day and petabytes of data. So that's the scale we need to handle. And one more thing, we didn't go with open source. I mean, with self-managed. We went with what's next, so IBM. There's a couple of reasons for that, which I'm going to explain. So we get some customized features, which is nice, and we also get a nice UI, what's next data. But the most important thing is the level of expertise we're getting, because it's pretty hard to find Presto specialist in Europe. It's actually very hard, and you really need to know what you're doing to set up the Presto cluster the right way. And since, as I mentioned, we are focused on being cost effective, that's very important for us to have the clusters set up the right way. So it's really valuable to have the level of experience available. All right, so Presto, as any other technology, has strengths and weaknesses, and we focused on just a couple of them, just a couple of strengths and things that we don't like as much. So let's go through them. Some of them are pretty obvious, like high concurrency workloads. Yeah, this is probably what Presto was created for. So it's definitely on the list. And strict query parsing might seem counterintuitive, because Redshift was like accepting everything we threw at it and just doing everything it could to parse the query. So like automagical conversions, casting, things like that. And it's not the case in Presto. But why we think it's a good thing that is happening is that when you submit a query in Presto and it runs, then you can probably be sure that it's technically correct. So you're not going to have any hidden problems with it because of casting or anything. And one more thing. So actually, the last point, I had it in the presentation before, but yesterday in the workshop we literally ran Presto on our personal laptops. So this is exactly what proves my point. It runs on anything. It can also run on spot instances, which is nice for being cost effective. And also, most of all, it's open. It's open source. So we value that a lot at Bolt. And now the things that we don't like as much. So, for example, scaling is quite hard to get right. So that's because there's CPU-based scaling in Presto. That's like the baseline, and our heavy queries tend to rely more on memory. So we had to experiment with the node type to get the scaling right, to not have out-of-memory errors. And Java GC, well, let's just say we have high hopes for VLOX. So we're testing it right now, actually. So I hope it's going to go fine. And something like Spark has so checkpointing, that would be really nice to have. And also the lack of back pressure sometimes hits us in the way of out-of-memory errors when clusters tend to they want to use more memory than they have available. Yeah, so let's talk about Presto performance. So imagine this situation. You are an analyst. You come to your office, open some dashboards on a Monday morning. You want to create some reports from the weekend. Normal situation. You open up Looker. Looker uses Presto. Everything is working. You're happy. But then something happens. It turns out that actually there are a lot more analysts at your company, and they all start using Presto. And what happens is Presto gets overloaded and unresponsive. But well, I kind of actually spoiled what we can do in this situation, so I'm not even going to ask you. We can scale Presto, which is not that easy, as I mentioned. So we have a few strategies for scaling. So one strategy that we have and already discussed is CPU-based scaling. So it sometimes it needs some care to be set up correctly, but we can also have some optimizations for that to make our scaling better. We have quite unpredictable workloads, so we need more than just CPU scaling, because sometimes, CPU scaling can take a moment to scale the clusters up, and users don't always have this time, the time that is needed to ramp up the cluster. So we also set up time-based scaling, which is a very simple concept, and it handles the predictable loads very well. So like this Monday morning problem, we just ramp up the clusters beforehand so that they are already scaled out when people start using them, and then they scale down when we predict then the heat will be gone. So this is good for predictable workloads, but what about unpredictable workloads? So this is actually what we are working on right now with IBM. It's the query queue-based scaling. The concept is also quite self-explaining. So the query queue gets bigger, so you scale up the cluster, and query queue gets smaller, and you scale the cluster down. The concept is pretty simple, and we hope that it's going to take care of the rest of the problems we have that the previous two strategies don't resolve. Yeah. So we also invest in data mesh. This is not specifically about Presto, but about the whole data platform. So just to revise the core concepts of data mesh, there are 4, and we are going to talk about 2 of them today. So governance and self-service, which is kind of connected. It fits nicely into what we are building right now. So actually, this is also something that I spoiled on the previous slide. So not going to ask you about that, but I'm just going to jump to the answer. It's an important distinction that while the data platform team is the owner of the data platform, it's not the owner of the data. I mean, it can be. In some instances, we also have our own data, but mostly the domain teams are the owners of their own data. It's kind of a simple thing right now, a simple statement, but it was not so simple a few years ago. In the time of data engineering teams, centralized data operations, the data engineering team was the owner of all the data, but it's not the case right now with data mesh. And it's actually a good thing. So the domain teams are owners of the data, but so how can they decide who has access to this data? And it's not. I don't think there's a universal standard for that now, and the situation gets more complicated the more engines you have. So, for example, we have Apache Ranger for Presto and AWS IAM for Databricks, or you can have Unity Catalog, of course. But since we have two engines and two permission management systems, we need to upload the rules into both of them. And when it's a manual process, it's very error prone, and the data platform team becomes somewhat of a bottleneck in this whole situation. So we definitely don't want that. So what we are building right now is an additional layer, a system, a backend service that we would use to store the rules, to have the rules in our own database and just apply it to the engines. So that would take care of the unification of data rules, but there's still the question of how the teams can decide who can access the data, how they can actually set up the rules. There are very small letters on the screen, but we have hundreds of schemas, tens of thousands of tables. So it's hard to have a manual process to assign permissions for them. So we came up with this idea that people should be able to request for data access, and when they request for a table or schema access, then the data owner or the data steward can approve or reject this request. So this takes care of the self-service part. Last but not least, cost attribution. So they say that you have to spend money to make money, but you probably don't want to spend everything on data platform, or maybe you do. So we have this problem that we wanted to solve. We focus on being cost effective, but to be cost effective, you need to know where your money goes. If you want to know that, you need to know who spends money, and actually you need to know when you're spending money. You need to know how much you're actually spending. So how much your queries cost. So we came up with this solution to tag the queries with labels, and the label would be like a cost center that we can use later on to aggregate the spendings. And the other problem is calculating the query costs. So we experimented with that, and it turned out that the best metric for calculating query cost is the bytes, the bytes that are processed by the engine. It was the most stable metric that we discovered, and so if we have that, we have the necessary tools to tell people how much they're spending, and maybe that they're spending too much, and how they can optimize their cost. All right, so that's the present. That's what we have right now, and there's also another ghost of data platform yet to come. And why it's not a ghost? So when Scrooge was visited by the ghost, it was a wake-up call for him. So it made him understand what he was doing wrong, and what he needed to do to be a better person. And we actually already know that, so we're not really scared of that. We're not scared of future, more like excited. So it's not a ghost. It is not a ghost. It's something rather good for us, the future. I mean. So what we want to do is categorize the queries, and this is mostly to have the lighter queries running on separate clusters and heavy queries running on a separate set, because we want light queries to just flow through the clusters and complete, and not be blocked by the heavy ones. And we want the heavy ones to complete eventually. We also have the GC problems that I mentioned. So VLOX, come on. And there are some other plans, like investigating icebergs. So right now we are using Delta, but for Presto, we use the Hive connector. So it actually uses the symlink manifests that we have to generate so that Presto can read Delta files. But well, Tim was saying that the Delta features are kind of improved right now, so maybe we can also look at that. But Iceberg is also a promising thing. And cost cutting, for cost cutting, we are looking at spot instance usage, which would introduce like a solid cost savings, and also query retries so that we have less failed queries in general. Yeah, so as you can see, this is quite a journey. We started off with monolith Redshift, moved to modern lakehouse architecture, learned our lessons. In fact, we're learning still all the time. We have some new problems. We resolve them. We have some new features that we need to test, and we are building our own systems that we want to deploy in the near future. So it's an exciting time to build a data platform, and we feel like the best is yet to come. So thanks for listening to us. If you want to move to Europe, we're hiring right now. Yeah, so that's it for today. Thank you. So we try to set up the clusters so that none of them stay idle, unless there's a significant demand from business to just have something standing by all the time. We actually don't have that many clusters. We rely on scaling, but we need to have some number of sets to mitigate the noisy neighbor problem, and you know, different verticals have different needs. So we have smaller clusters for some of them and bigger for the other ones. So we try to keep it minimalistic, but at the same time we feel like it's absolutely necessary to have more than one cluster. Yeah. So the question was why exactly we chose the bytes metric instead of what was the other one? Yeah, instead of compute used. So that was a complex decision. I'm not an expert on that because another team member was handling cost attribution. But I was asking him before this presentation about what the metrics that we decided to use, and he told me it was the most stable one, the most reliable. So Kostya, maybe.
Only this one is working. Okay. Yeah. Okay. I'll comment on this a bit more. So generally, yes, there is a number of metrics you can use, from CPU time to memory to byte scanned and many others. We've experimented with a bunch of them, and this current approach may not be final, but it's the most stable from our experiments. And some queries can be quite CPU intensive, some can be quite memory intensive. So you cannot just rely on CPU time, because some queries take much more in terms of memory, and that's why also, for example, CPU-based scaling doesn't always work, because you can be bottlenecked by memory, for example. So out of all these metrics, byte scanned kind of, I would say, correlates both with memory and CPU usage usually, and out of simple metrics that we've tried, it works the best so far.
Right. So I think we're done.